This video is the first of the Cardano smart contract course, and we'll use the next minutes in order to make sure that you do respect some prerequisites in order to get the most from this course. First of all, you'll need to have some experience with any programming language in general, and this is because in order to write smart contracts, you'll need to have clear some common patterns between programming languages, and if that is not the case, in the description below you'll find a link that will bring you to the programming basic course on this channel, which covers everything you'll need to know in order to feel comfortable with programming in general. The second assumption is that you are on a Unix-like system, and that is because most of the Cardano-related software, at least at the moment of registering this video, only works on Unix-like operating system. In this course, you'll see me working on a Ubuntu OS, and if you happen to be on Windows, then in the description below you'll find a link that will bring you to the Ubuntu webpage where they have a nice tutorial that helps you to set up a virtual machine on your Windows computer. Alright, and with that, let's see what you'll need in order to write Cardano smart contracts in particular. And you might know that once again, at least at the moment of registering this video, the only way to write Cardano smart contracts is by using Haskell. So it should be clear why Haskell is in this list of prerequisites. Now, you don't need to be a total expert of Haskell, but I'll give you here some concepts that you may want to add in order to follow this course. And for sure, you may want to be comfortable with the syntax of Haskell, since being Haskell a functional programming language, if you come from an object-oriented one, it's very likely that the syntax may look awkward at first, so you should be comfortable with the syntax so that you can focus on the concept of the course. Then you'll need to know some general Haskell concepts such as lazy evaluation or monads, because even if these two examples, which are lazy evaluation and monads, are not directly used into the on-chain part, they are useful in the off-chain when written in Haskell. Otherwise, we'll see that the on-chain part is just a function and, well, maybe some data type. But if you have a general understanding of the keywords that Haskell are doing, you should have no problem with that. And also, you should know how projects in Haskell are handled. And this is because, as we'll see also, the library used in order to write Cardano smart contracts has a lot of dependencies. And in order to manage those dependencies, having an understanding of how projects works in Haskell will be definitely useful. So if you are looking to dive into Haskell, on this channel you'll find also a course that covers the basics of Haskell, and you'll find a link to that playlist also in the description below. And then last, this is more a disclaimer than a prerequisite, and it is that Bluetooth, which is the library that we are going to use in order to write Cardano smart contracts, is a relatively new library, and that means that the code that we are going to write through this course may vary, the name of the functions may vary, and in general, well, during the course, we'll also see how to use the documentation given in order to know what to use, but just don't be scared if you can't find at the time of watching this video the exact same function that is present in the video itself. So with that, it should be everything. Before closing this video, I want to remember you that this course is free to watch, but it can be even better. If you want, in the description, there is a link that allows you to delegate your ADA to the Harmonic pool so that you will earn interest while supporting the creation of this content. And with that being said, this is all for this video. Remember to stay centralized, and I will see you in the next one. Bye bye.